1, 2, 3, 4, 5. Welcome to another live session. Generally I don't expect anybody to actually be joining me, so this is basically a way of getting round my impatience. So I don't plan a script, I don't write a script. I like to get things done. I don't want to do any editing, so by doing it live, then I can sort of skip all that bit. Just until I get back into having some ideas that I think are worth spending a lot of time on. So everybody's unique. There are no wrong answers. And telepathy is not real, but social media is getting close. So I have a ARP Foundation t-shirt on today. As one of the organizations that I support. So basically the ARP and the Bob Moog Foundation are charities that I provide support for on a regular basis. There are a few others, but mostly those are the main ones. Okay, so I'm playing with the sound levels today. It's going into the red on OBS. I don't know if that's too much. Let's dial it back just a little bit. The worst bit is I don't want it to be quiet, because I do tend to talk quietly if sometimes, and that's means that it's harder to hear what I'm doing on the stream. So I've been playing with a Tinymud multi-user dungeon, which allows many players to play in the same environment. And I've been doing this since the 1990 roughly. When I was at Imperial College, at that time, I looked at the code and ran it on several machines, one of which was a Microvax running Ultrix, and then later on a DeckStation 3000 on my desk. And Imperial College initially in the 80s was mostly X25 OSI protocols. We had a X25 linked to the outside world, and the UK Academic Network, JANET, J-A-N-E-T, at some point started to switch over to TCP/IP based protocols. University College London, UCL, had a node on the internet back then, the ARPANET, and that mean that we could actually get internet traffic to the campus, whilst in the 80s we put in a thick net backbone across the campus, and by the time I left in 94, we were just about starting to put in twisted pair with thick net and 10 base 5, the twin net type thing. So anyway, in the early 90s, having a Microvax running Ultrix was an easy way of running this software. I also ported it to Windows 3. Whatever it is, or DOS. So to do that, I didn't have networking, Ethernet networking. What I did have is multiple serial ports. And so by abstracting the main loop, which uses what's called a socket call, by abstracting that, basically having pseudo drivers, which allowed me to have non-interruptible serial I/O and other networking protocols other than just TCP/IP. In the source, which I haven't put up, in the source that's actually on the GitHub somewhere, there is an rs232.c which provides the serial port. So I did a lot of modifications to the original Tinymud, and one of the things I wanted to do was to make it more flexible. The original Tinymud had lots of built-in commands. It allowed you to, as a user, if you had the building privileges, to create rooms and link them together with exits. And this allowed you to do state machines. So you could do quite complex stories and puzzles. And one of the capabilities of an exit that was already available was a lock function. So you could say you could only take this exit if you're carrying an object, or if you were carrying an object you couldn't take this exit. If you're a certain player, etc., you couldn't do it, or you could do it. And those, you could have arbitrary Boolean expressions. So you could make fairly complicated logic that way. But what I didn't like at the time, I thought was too restrictive, was the fact that they had built-in commands, which obviously at the time meant sense, like get and drop. So if you pick an object up, you use get or take and drop or throw, or whatever. There's a lot of different capabilities. So what I thought was I was going to use this is in the early 90s. I'd always wanted to do something like Smalltalk, which used this message passing metaphor. And I had briefly played with a machine that had OPL 432, which was a Smalltalk style operating system for a machine. So message passing, I thought, was a fairly clean way of implementing this new code. And so what it does basically is that one way of looking at a room and an environment around the room is that a room has these exits, and you can think of the exits as a dictionary. Each player now, in my modified version, also has exits attached to it, as do the things, the thing objects. So each object, room, player, and thing have their own dictionary in the form of these exits. So that is a very powerful technique for doing fairly complicated but a fairly advanced functionality. So basically, when an exit matches, then the lock function is evaluated. And the lock function I'd added were things like I had a move and a few other capabilities. I also took some of the hard-coded operations, such as sending a message to the user on failure or success, and again merged that code into a lock function. So another thing, this just goes on and on. Another thing is that exits, basically like other things, have an owner, and an exit starting with a dot, a period, is basically only visible to someone who owns it. It's matchable, but it's not visible. So, but what you tend to do is you tend to have internal commands, effectively, which use the dot, and then they can provide aliases as a more general purpose command, which are not hidden, which call the special purpose command. This all sounds a lot like a fairly complicated system, but it actually worked out really well. So I can show you how a simple GET request allows you to pick up an object, or tries to pick up an object. So we have on the screen here the lamb object, and because I own it, you can see that there's a object number after it. So I can say examine lamb. And you can see that the lamb object has an owner, which is my command. I did do age handling differently from the Tinymud code I saw recently, but I do have the concept of an age. So this object hasn't been manipulated for 33 years, which is about right since it's 2026, and this code was probably added back in 91, 92. To provide, since I'm doing every object has its own dictionary of exits or commands, and the built-in ones are now removed. Instead of having to replicate all the commands such as get on every object, I added a class capability so that there's a objects, rooms, and players can have a class. And a class, of course, is just another room with exits, except that normally a classroom, yes, pun intended, is not designed to hold players. It's only designed to hold exits. Obviously, classes can have classes, etc. So you can have here, for instance, this lamb is in the class Shades Treasure class, and the idea is that objects of the same class can obviously share all the same exits. So this object, the lamb, has a .get and a .reset. The pound sign is a wildcard match, which matches the name of the object when you try to match it. You can have an asterisk, which is a generic match anything, but .get pound sign will match the lamb. So if you say .get lamb, it matches. If you say .get ball, it won't match. As opposed to if you had an asterisk there instead of the pound sign, a .get lamb and .get ball would both match. So the pound sign and star asterisk are basically wildcard matches, except that the pound sign has this extra functionality where it only matches the object, name of the object that it's attached to, or is currently what's called the sender, using a message passing metaphor. So we can look at the reset. We'll look at the reset first. So the reset basically is how objects go home in this version. In the original Tinymud, there's a concept of a home, which, if set on an object, allows the object to be put back to some known location. When I translate a Tinymud database, I convert that into a .reset command, and it just moves the self to the designated place to be. In this case, it's object 3738. So again, if a regular user looks at the lamb, these commands are not visible because they start with a period, and then the regular user doesn't own the object. So one of the things like move and these things, some of these commands actually allow you to change the effective ID of that's being used to execute evaluate the function. So this is a very simple move. There is a database-wide command called @reset, and if an Arch wizard runs that command, then a .reset message is sent to every object in the game, and that basically resets the game at that point. At the moment there is I'll walk you later, a robot which basically has exits such that the game resets about once every hour. This stops players from hogging resources, is the main reason. So let's look at the get object, get exit. So we'll examine pound 1782. So this is a sort of bit of a simple in-joke. We're in a room in a location called Broadway, and there's a lamb. So if you're a Genesis fan, you know the album "The Land Lies Up on Broadway," and so this is just basically a joke about that. If you try to pick this lamb up, it just says a message at you saying that the lamb gets up and wanders away. That's just a bit of fun there. So let's show you some of the sort of housekeeping that makes this type of modification plausible. Before I do that, let's go over here. I forgot to bring up any. Where is my mouse? It was there. There it is. Oh, I'm on the wrong monitor. Okay, here we go. So what I'm going to do, just quickly, just drag this up here. Go to YouTube and see the chat section. I should bring the chat up in OBS, but it's not currently showing, and I don't really care how to work out how it works at the moment. Yes, content, live. There we go. Okay, so I'll bring up that chat section just in case. I don't think there's anybody in chat. Welcome to chat. There we go. So at least we have a chat now. Of course, the obvious thing is that this game itself is live, so you can actually, instead of using YouTube chat, you can actually come in and log into the game, because it's a multi-user game. So as I said earlier, most of the built-in commands were moved out of the engine, and are now implemented as part of the lock functions on the objects. Since you want pretty much every object to have some form of get command and a way of doing that without writing thousands of copies of the command, what happens is that there is, for each of the different types of object, there is a default class. And the default class, there's a default class for rooms, the default class for things, and default class for players. So when exits are being looked for, iMessages basically an exit now is a message pattern. So when you send a message to the room, that messages are matched against all the exits. Then the ones that matched are put in a list. It also searches the class of that room object, and the class is class, etc., until it gets to the end, and then it goes and searches through the default. So you can put you can have everything in the default and don't have to have much in the way of classes in between. The downside is that there is a lot of stuff being searched. So there is a capable way of shortcutting some of the searching. So because one of the ways makes this engine interesting is that when you have all these different matches for potentially for the same object or different objects from one message, what the engine does is it takes that list and randomizes it, and then it starts to go through each of the exits, evaluates the lock function. If the lock function returns false, it moves on to the next one. If the lock function returns true, then it goes to the does whatever the exit's destination is, which for most things which are not room exits, it doesn't go anywhere. So just the side effect of the evaluating the function is what happens. So you can have a situation where you can have, say in an area there are like 3 or 4 different potential matches, but you want the one in the current room only to match rather than the ones in the room's class. There is a flag which you can set to called final flag, or found flag, which basically means that if you see this flag on a matched exit, stop searching. So it's actually it can be used efficiently to when you don't need the flexibility of the full randomization. The randomization allows you to have ambiguity. So that's one of the nice things about this engine. It definitely handles ambiguity in a certain way, and at some level, the modern AI ambiguity, where it picks the most potential probable word next, when AI is generating output, you do sometimes get, you don't get the expected result always. The other thing about Tinymud and this game is, since it executes commands from the players in a sort of rotation and limits the rate at which players can enter commands, it means that you can enter a command, like pick something up, but before your command is executed, someone else's command that picks the same thing up happens. So the game handles that too. It's not usually an issue. It's not usually a failure, because there are no wrong answers. So, but the rate limit on commands means that someone who can type faster while using some form of client can't race around and pick everything up in one go in a few seconds. They are limited to at the rate at which they can enter commands, and the game doesn't tell you when it's throwing. It just throws commands away if you enter them too fast. It doesn't tell you. So let's go and look at some of these classes. These classes can have lots and lots of exits, so we might only end up looking at a few. There is cases where you want to have a wizard authorization, which is why there's a default wizard, and you want just a regular player who has no special features. That's what Beaker is. Beaker's actually an original player in one of the early tiny databases, and I just used that class, that player object, to be a generic player. Let's have a quick look at some classes here. I haven't prepared this, so we'll just click in the right place before I start typing. Forgot to put the pound sign. So this class has a class of a class. So here, this is a class used, and it has some specific exits at this level. It also has a class. And using a typical message passing style or object-oriented message passing, for instance, here we have an exit called in shades. And what this does basically just means that if you send that message and it returns true, that means you were in this part of the database. It's a fairly simple trick. There are also a sort of exits here for the random directions. So instead of getting a "I don't know that direction" message, you get some different message, and it can be driven through what you see here. So this is a class of a class. It's designed for one of the database objects. One of the areas in this database is called shades, and rooms that are in shades typically come down to this class at some point. This is the top level class for these rooms, although it does pass on to the default room as the search keeps going. So anyway, we'll have a quick look at some of these exits, just to see what they're going to say, because it's probably going to be something very simple. So one of the things I want to do eventually is obviously build into the web front end a better way of doing this editing and having it like an editor. So there you go. It just says you can't go that way. How boring that is. Nothing interesting going on there at all. So anyway, let's go and look at these defeated objects, because this is where things get really interesting. So we'll look at 1.5, the default thing class. Yeah, there's a lot of them. So some of these are just aliases that you might type in at any point. So you might want to try breaking an object or sacrificing it. And so all of these exits are available to a thing. So we could say drop lamb, reward lamb, use lamb to something, etc. Some of these are simpler than others. So let's look at the 1566. I think that's probably the one we're interested in. That's going to be an alias. So here we go. Now we're starting to use these lock functions in a more interesting way. So what we have here is the key. First of all, we're going to pick something up. So first of all, the has function is applied to the sender, which is usually which would be the person, and self would be the object that matched. So basically, does the person already hold the object? So if it's true, the and function then sends the message you are already holding. $0 is the self shorthand. So if you're not holding the object, it also then sends to the user the message .has $0. This is an alternative way of checking, because, for instance, it might not be a simple object. It might be something that has more functionality than just a simple exists. So in this case, the has .has message is being used, and so objects can be more flexible in whether you can pick them up. It has the opportunity of responding in various ways. It doesn't have to be just you don't have it, etc. And in this case, it sends the same. If that's true, then it gives you the same message. It says you're already holding it. So after that, if that fails, we have a send.get command. And if that succeeds, it says you picked it, basically it was taken. And the OSUK message sends the message to everybody else in the current room, which says that you, the sender, picked up the object. Now this, we've been using this exit to pick up the lamb as an example, and because remember the .get command on the lamb failed and said it didn't work. So anyway, this is why this exit is 15 seconds old, because it was accessed recently or referenced recently. So that gives you an example of the level of processing. What is interesting is that part of the reason to do this, and what it allowed me to do, is that I have a number of attributes that players have. For instance, the original Tinymud had pennies, and then I also added health points, and then we had, so to do that, we added, there are functions lock functions that is, to wound someone or heal someone, so they adjust the health. You can reward and you can pay functions, so you can say how many pennies is required to transact something, or when you achieve a goal of some sort, you can reward the player by some amount. And none of this is hard coded into the engine. It's all part of the database. One of the things I needed to do is to do things like adventure and the Zork type trilogy, was you needed to be able to basically attack things. And the interesting concept there is that in order to attack something, it basically has to export a kill exit. So it has to be something like kill pound with star, where star is a wildcard. So basically, kill Tom with axe. If Tom's in the room, kill Tom would match the pound sign, and axe then would be passed to sent as a message as part of that, and then that would be evaluated. So let's have a quick look at, say, there is a kill command here. I don't remember if this is the one that's useful. Okay, this is the humorous version. I think it's already dead. 99 years old. That means it's literally never been matched successfully. Okay. So anyway, so I've given some examples, some ideas of how this is interesting idea, and how it's very flexible. And so I say things like classic games like Adventure and Dungeon, which are fairly large C programs with a mixture of an engine and a data. I was able to modify the C code to basically dump the rooms, the exits between the rooms, and also automate a lot of the logic that they used. And Adventure and Dungeon have been in this database for over 20 years. I used to have a lot of players back in actually it's probably 30 years now. Back in the 1990s, I had people playing Dungeon. And when you take a single player game and you make it a multiplayer game, you then also have to look at how people cheat. So you have to sort of add anti-cheat capabilities. Sometimes is just generally by changing the layout slightly. removing some of the commands or adding extra objects. So, for instance, in Adventure there's dark areas. So obviously with the dark area, if you use the look command, it basically sends a .look here, and the look command for that room or dark rooms, if it's classed as a dark room, will send like a .light or .has light to the player or to the room to see if anybody in the room has light. So you can have something simple like that. So one player can carry the light, and other players can see. If that player leaves, then everybody else is now in the dark. It's a very simple way, but it shows the power of these basically having dictionaries attached to every object. And so by moving objects around, what's available and what can be done is dynamic. So there are lots of other little things which make this interesting, most of them which are pragmatic. So I had them just because I tried something and I worked out how to do it, I may have added that code. I try to minimize the built-in capabilities, but I actually sort of failed miserably at doing that. There are way too many, well, not way too many. I added things really under duress. So if we look at, say, built-in commands, is a command. So everything starting with an @ is a built-in command. These are only matched after the search engine has not found any exit. So you still can override everything here in a room. Here's the second page. A lot of these are identical to the Tinymud ones. Maybe they're an @ command when they were in a Tinymud. They weren't. They didn't require the @ command and vice versa. But things like toad, unlink, unlock, version, shutdown, set. These are basically the same as the quit. These are basically the same as the Tinymud code, and they literally haven't changed. The functions of Boolean functions. So you have the standard operators and, or, and not. There's obviously there's a @ which basically just does test a lock indirectly, and then you have functions like age, which basically the age of the current receiver versus the time or the specified time. We have exec commands, ones that happen to do it silently and ones that do it loudly. You can then have the fail message, so that basically sends the message to the user and then returns false. You have false. There are ways of doing false, like something and not something, but it was easier just to provide the capability directly. So flags allows you to test bit flags on objects. There are a lot of flags, apart from the first 3 bits I use to determine whether it's a room, player, or a thing, or an exit. But the other bits are used for different things, such as builder, wizard. So the has function basically tests if the location has the object, returns true. Location is usually the room or the player, but the things are allowed to have content as well. So players can carry things, room carries things, and marked containers can have things inside them. So has works on all of those. I said heal, that's usually as part of the health system. Level is a way of basically tracking progress. There is a set of level tables based on pennies. Move, obviously, is a very basic move object, so to like a teleport command. Suck and fail are, again, sending it, that message gets sent to everybody else in the same room. So again, pay is a part of the reward system. Promote, there's part of the level system. You can push a command onto the user's input. This is means that the command executes in the obviously as if the user typed it. There are rare conditions when you need this, can use this. Reward, again, you can give players pennies. There's a random number generator, not very good, but it works. So you can actually have it just randomly decides to succeed or fail. So you can use that, and that means you can have more than just the initial random stuff. You have teleport, it's like the same as move. True is obviously true. Wound modifies your health points. Now, back in the 92, 93, I think it was, I discovered that there was a thing called a BSX mud, which used crude, simple graphics, polygonal graphics, and so I started trying to support that. So that's what show does. Show basically check to see if you have a multimedia representation of an object, and does the client support multimedia operations. At one point I had a Java client which supported the BSX style graphics, and it also supported, I also had a Windows client which supported video and audio, but in the 1990s, with computer limitations, video was basically 32 by 32 pixels, but it did work, but very slowly because networking wasn't very fast. So you can basically show, hide, and define multimedia objects. There's obviously an obsolete version of exec and an obsolete version of drop. I believe, let's see, I don't think there's any more pages, maybe some more. Yeah, there's a few more. So the BSX capable stuff, I first implemented these suck and OSUck messages. I don't remember why you can test to see if something's a particular class. There's multiple ways of doing that. Given it's for the multimedia, there's a concept of position, which has an X, Y, Z coordinates. And so the position function allows you to manipulate that. And that's what the within is part of the capability there for multimedia objects. Empty, and recently I added a sys command. The idea here is that I want to be able to interact with processes on the MUD server, so I can try and do an AI integration. And so I've implemented a simple sys command which has a very limited capability to run and execute code on the server that the MUD is running on. and that code can do simple things. One of which I hope would be to call a local LLM, but that's currently more on the back burner. That's what I meant. What else is there here? I might as well get this over and done with. Levels and really boring. Based on pennies. There are basically blocks, so that the dashed lines you have to do a promote to get from one to the other. So from level 3 to level 4, you have to get it promoted, and obviously promotions are buried in locks, so you have to solve puzzles or certain things to get it promoted. Obviously levels are exponentially growing roughly. So the idea is it doesn't matter how many pennies you get. As you go up levels, you also find there are objects which have more money to start with. There's so nominally you can get all the way up to wizard. But usually by the time someone's been playing long enough to get this far up into the thing, they chat with me and they become an actual wizard and start manage the game engine. Because that's the main thing that takes time if you're running a game engine. You need to be able to manage it. So it means you have to be responsible for monitoring players' issues. If players get stuck, they need to be able to get reset. So what else was there? Levels, players, things. Okay, so we can do. Let's look at transport. And find train. Uh, 7965. So, because you can move players around, players are only allowed to be in a room. You can't put players in a container. You can't put players in other players. Players can't pick up players, etc. But so what I implemented is if you move a player to a thing or another player, what it does, it works out which room the thing is or player is in. So if you have, say, a button in your pocket inside a bag, and you move another player to that button, what it does, it says, oh, the button's in a container, the container's carried by this player, the player is in this room, and it'll move the player to that room. One of the nice side effects of this is you can have vehicles. You can have things like telephones, implemented just by moving players around and putting them back when the lock function is evaluated. So again, most exits attached to players and things don't point to a room; they point to room 0, which basically means you don't go to room 0. It's like doesn't exist effectively. So what typically happens is that after a lock expression has been evaluated, if the lock function fails, then the player is put back in the room they were when they launched when that message was evaluated originally. So a lock function can move a player to another room. It can do other functions within, obviously, that lock function, such as give, say, a local player a message or something. And then if it returns fail, then the player automatically is returned back to where they started. So there's a simple way of implementing things like telephones. If it returns true, it leaves the player wherever they are. And so, for instance, if you have an object which is inside the train, and you teleport you move the player there, then whatever room they're in is the room they're in from the train. So what typically happens is that you can use this capability to do a lot of interesting things that obviously you can't do with a hard-coded engine. So we've got vehicles. We do have fighting capability, because you have to have it to do dungeon and adventure, because they both have fighting where you have to fight the NPCs. So the last thing I probably want to talk to on this session is robots. So this engine implements robots. A robot is a player object that the game engine moves automatically. The way you program how a robot moves is literally the engine picks every exit the robot could take and then randomly evaluates them until it finds one that's true, or they've all been evaluated, just as if you typed it in. To make the search smaller, more directed, any exit that's owned by the robot is preferred. So if any exit's owned by the robot, then only exits that are owned by the robot are used. This also is augmented with a robot flag on an exit. So if an exit has a robot flag, all robots effectively own it. So that's another way. So the simple thing to do is to build a simple set of rooms and have a set of exits between those rooms which have the robot flag set. And so therefore any robot that gets into one of those rooms will just follow the trail. Every time it moves, it'll move on to the next state. Now, of course, those exits can also have lock functions, and this is how the game resets. There is a clock robot, and what the clock robot does is it obviously just sits there doing what robots do. And in the timer room is where it currently is. There are a number of exits, and the exits use the age function. So they can as you can see, the game just output a message saying there's a gong strike. You could hear a gong striking, and that was the clock robot. So that exit that outputs that message has an age function which says it has been, if it's been over an hour, the robot can take that exit. It also has age comparison between some other exits, such that the gong will next strike 2 times. There we go. And the next time around, the clock robot executes a reset command, and the game puts everything back to where they started. Again, so the robots are moved about every 2 seconds when a player is logged into the database, and they move about every 20 seconds when no one's logged in. So the game does run continuously, and it basically has been running more or less continuously for 30 years. There are times when I was moving and I had to take the game down and put it back up again. And obviously with this database, I'm working on various things, so it's down for a few minutes now and again as I update the engine and try different code out. So some of these robots are just standard NPC type things. If you go to adventure, I added this robot called Trog, and Trog just runs around adventure near the beginnings basically. If you go to the Dark Castle, there we go, you'll find there's a robot called Annie running around. Annie and Jack run around. The no, not Urchin. Where is it? I'm missing one. Sprite. Oh, I don't know where Sprite is. Okay. There's a robot called Sprite somewhere, which I have to find out, which is basically blocking a path which you would need to take to get to somewhere else. Somehow Sprite is not running because I don't see it in the list. Or it could be that there's another. I don't know, is that robots one? No. Oh well, there you go. Okay. Let's see what it's doing. Oh, it's there. I don't know why it doesn't think it's running. Oh, may not be. Never mind. So, part of the fighting sequence that you can implement, I mean, anybody who can add objects to the database I can build can implement their own fighting mechanisms. The only thing you need is basically you need to be able to export some form of kill command which can identify the recipient of the attack, and that's basically it. So what I did here is the sprite has basically when you attack something, a defend message is sent to the receiver of the attack, and that if that returns false, then the attack is basically fails. So you can basically build up a probabilistic defense against weapons. Obviously weapons can have different classes if you implement it that way, so there can be weapons which implement more damage or less damage, etc., and it's all basically built out of the logic of the exits and the logic functions that the game engine implements. So it's not a general purpose programming language, and it's not designed to be. That would make it have other issues, I think. It is very much tailored for the environment. The multi-dictionary based system, dynamic multi-dictionary based message passing processes are a very powerful technique. You can do a lot without knowing any programming, just by knowing about digging rooms and opening exits between them, and then describing what that room represents. using your imagination and the player's imagination, the reader's imagination, to come up with some very interesting ideas. If you're just doing a simple text-based system, then you can very quickly put together stuff. You can probably take a book, a well-known theme, and re-implement it fairly quickly. Some of the robot mechanisms I have implemented where an object the robot is carrying has a robot exit, such that the robot will basically move in certain directions or to another room. In that room, they might say some dialogue, then move on to another room. And depending on who else is in the room, like there's maybe multiple NPCs, they could have a conversation, and it's scripted. So you could have scripted conversations between the robots. That way, the NPCs. So yes, you can do a lot with it. So what I'm working on currently is a way to allow designated users to upload their own database for people to play with using the same engine, and so they can edit the database offline and then upload it. Because if you add objects to the current database, then you can't, it gets mixed up with all the other objects in the database. So the engine supports the concept of multiple databases and portals between them. So we can set up, use the base database and allow users to upload their own databases and then have portals between them, and then save their database after they've made changes, or they want to update it with a new content without getting muddled up with the base database objects. Currently I'm thinking of when a player goes through a portal, the database they go to, if it doesn't have that player name, it will then create a player of the same name. Although players only really exist in the base database, and the base database is where it is determined if a player can create or upload or change a local database for their use. It'll sort it out. So I have a way of now uploading a database over the user's connection. I've been working on the web client here, so I'm looking at providing this load and save capability. Well, you can't see that for some reason. Okay, you can't the way the web browser works. The OBS works. There's a pop down here, and the reason that you can see this word builder here is because the web client parses what is being sent, and if it sees an object reference like this at certain places, it knows that I own objects, and therefore I must be a builder, and it turns on this builder flag. If I don't have that, I just reload the game. So go into dungeon as a guest. You see the word builder doesn't appear, so it knows that this player doesn't have builder capability. Oops, I got someone on my head. I have someone in chat. Hi, chat. There's about a 20-second delay between what I type and what appears on the chat window, I think. Oh, okay, let's just cut him so I can... So if the game is up, you can get to it through this URL. Although I take it down without notice because I'm doing coding updates on it. What does dot 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 mean? Don't know. Maybe you can guess. Anyway, you get the web page. Okay, so I'm going to end this stream. Yeah, it was fine. What else do I need to do? Probably not much. Yeah, I think that's... There we go. Tinymud. Do I have... Probably... Didn't mean that. Screw this one. So this is adventure. Not sure which version I modified to extract the information. But this is one of them. And the Zork / dungeon. Oops, what am I doing? Oh, yeah, you're just catching up over there. So dungeon basically in this database is Zork 1, 2, and 3. So it was, I don't remember which way around. I think Zork dungeon it came out first. There were some issues, so they changed the name to Zork. They had to split into pieces because the game was too big for most of the machines at the time, like CPM. It's hard to remember how small things were. I am looking at implementing a ZIL translator, so I can take ZIL source and put it in as a database. So the idea is I should be able to have the Zork Infocom adventures that are in ZIL potentially as run by this engine and make them multi-user as well. What else is there? Adventure, I think mentioned adventure earlier. So this is basically adventure. Because there is a robot running around, I gotta fix that. No, it's fine. There's Trog. Yeah, he's left. Scroll the window backwards around. That's over here. Formatting, there shouldn't be 3 lines. I need to put, I'll sort that out. So the web client does parse what's being sent to the user and highlights things so that, for instance, these are drop commands. So I can drop the bottle. Yeah, either tends to pick things up. There we go. So it picked up the bottle, which is just more for an annoyance than anything else. Trog doesn't attack you here, so that's not an issue. It's off the bottom of the page. Okay, so I've got some formatting issues there. Getting the font size dynamically changing is quite hard, and it's one thing that's been a bit of a pain setting up. So here, again, this is basically a modified Tinymud. There's none of all of what you see is implemented in the database as lock functions and rooms and objects in rooms. There you have, since you have message passing and things, there are multiple ways you can do the state handling. Sometimes you just swap an object, like the open grate with the closed grate. So when you unlock something, open the grate, it actually switches a different object, and so you can only go down when the open grate is present in the room. You can't, obviously the get function doesn't allow you to pick up the grate, etc. So all these sort of things are doable purely using exits and lock functions. So in about 50 minutes, 50 minutes or so, the game will reset everything back. All these objects will get back to the beginning, so someone else can come in and play. What is the... There you go. There we go, there's the look command. Basically, it gets sent to the room. If the room is dark, a dark room class, it checks to see whether there's light. Someone's carrying light. Very message passing and this dynamic dictionary stuff is a very powerful metaphor. macro processing, all those sort of things are doable. You can actually do quite a lot of computation without having any actual variables that you can directly manipulate. Pennies can be manipulated. You can count to the pennies, though you can't test whether the pennies has a particular value. You can obviously you can heal and wound, so there is a health number counter associated with a player. Things don't have a number that can be dynamically changed. So you can't, but you can do simple things like put 5 pennies in a room, and so once people pick out the 5 pennies, there are no more pennies there. So you can do that sort of restricted resource capability, but you can't have 1,000 pennies without creating 1,000 objects easily. Yeah, you could probably have a 1,000 penny object, and a 100 penny object, and a 200 penny object, and do the logic so that logically you can have an arbitrary number of pennies, but you can probably do it obviously, but that's probably overkill. In part of the dungeon game, there's a maze which has ladders. You're inside the maze, and when you look, it actually prints a map of the maze around you. It does that by basically momentarily moving you diagonally to the one corner, moving 3 times sideways, moving you back to where you started, and moving 1 to the left, and then 2 to the right, type of thing. And then basically it does 8 or 9 things, so look commands effectively, and prints out basically a fairly crude map. I was thinking we could probably implement a chess game, make it play chess, but that's a lot of, well, it's only 64 rooms, but I forget how many there are. I mean, there's going to be, you'd want probably at least 8 times that in terms of exits, just so you can move north, south, east and west from a room. And then you probably want the pieces to be able to work out things. So you could probably, with a few thousand objects, have a chess game capability. So anyway, it's getting late here. It's Friday now. So I'll wave goodbye. And remember how to stop streaming.